Hello dear students, today I am going to explain a question in which many students have trouble visualizing. Okay, in this video I will give you a crystal clear explanation which you will never forget. Okay, so let us move on. Let us first analyze the question. To mop clean a floor, a cleaning machine presses a circular mop of radius r vertically down. Okay, with a force F and rotates it with constant angular speed about its axis. So this is a mopping machine. It is pressing it down on the ground with a force F and rotating it with a constant angular speed. If the force is distributed uniformly over the mop, so this force that we are pressing it with is uniformly distributed over the mop. Okay, and coefficient of friction is mu. So between this and the ground, the coefficient of friction is mu. The torque applied by machine on the mop. So let us say we are pressing it and rotating it. What is the torque applied by us to rotate this mopping stick? Okay. So let us move on to analyze what forces act, what torques act in this question. Okay, so we are pressing it with the force F. Okay, and there is normal reaction force acting everywhere uniformly. The yellow arrows that you are seeing is the normal reaction force. Now, as it is turning this side, friction will act in this direction. So the red arrows that you are seeing here is the friction direction acting on the mopping stick. Okay. So let us move on to solving the question. This is a top view and this is a side view. Okay, and let us. What we'll do is we'll take a see this the force is uniformly distributed. Friction acts everywhere. So the friction which is acting further away from the center applies more torque, right? So what we'll do is we'll take a small area wherein the torque of the friction is the same. Okay, so I'll just take at x. I'll take an element dx. Okay, so this whole area which you are seeing now, this whole area we are talking about right now. Now, what is the normal reaction force in this area? That is, let us say it is dN. Okay, dN equal to, this force is uniformly distributed, so I can write the force per unit area is F by pi r square into the area of this. Okay, so the area of that is 2 pi x dx. Okay. Next, what is the friction force acting? The friction force dF equal to mu times dN. Okay, friction is mu dN. Kinetic friction is acting. Okay, because there is a relative motion between the mop and the ground. And what is the torque of this friction? d tau equal to dF times x. Okay, so I'll just write this d tau equal to dF. What is this dF? Mu times, what is dN? Pi cancel, 2f x dx into x, this will be x square dx. Okay, so this is the torque of friction acting on the mop. To rotate it with constant angular velocity, we or the machine needs to apply the same amount of torque. So to find the total torque, we'll just integrate this. From where to where, tell me? There is friction acting all throughout. So from x equal to 0 to x equal to r, will integrate this. So keep the limits from 0 to r. Okay, and yes, we get the total torque as 2f mu. Okay, x square dx will be x cube by 3, so r cube by 3. So r square, this will get cancelled and we'll get this as r divided by 3. Okay, so this is the total torque that we need to apply. Okay, so I hope you have understood how to visualize this question. Okay, and see you all in the next video.